Hi, boys and girls. Today we're going to look at lesson 1-2, Understanding Whole Number Place Value. It's part of Envision Math, and it carries on from yesterday's lesson. First, I'd like you to do a warm-up. A group of 12 students goes on a school field trip. Of all the students on the trip, 6 are in 3rd grade. Which fraction is equivalent to 6/12? Go ahead and solve. Well, 6/12 is what we call a fraction that is not in simplest form. You can reduce 6/12 and put it in simplest form by dividing each your numerator and denominator by 6. 6 divided by 6 is 1. 12 divided by 6 is 2. And that's why D is your correct choice. How about what fraction of these boxes are open? Go ahead and solve. Well, a fraction is a part-to-whole relationship. So you want to look at how many are in the whole set. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 in the whole set. Now what part of that whole are open? So 1, 2, 3, 4, 5. And that is how you have the correct solution of 5/12. Yesterday, we reviewed place value. Here's a place value chart, and we always look at each of the sections of 3 digits here as a period. So this would be the ones period. And in the ones period, or in the units here is your ones, tens, and hundreds. And the next period is your thousands. And it's the same pattern, the 1,000s, the 10,000s, the hundreds. Then you have your millions, the 1 millions, the 10 millions, the 100 millions. So that follows the pattern. And of course, to the right of your decimal point are fractions of numbers expressed as decimals, tenths, the first place. 2 places to the right of the decimal is the hundredths, the thousands, and finally the 10,000s. Let's look at our solve and share. The population of a city is 1,880,000. What is the value of the 2 8s in this number? How are the values related? Use the place value chart to help solve the problem. So we like to supply you with a place value chart. And how you would do this is write this in the number. Look at this number. The whole number is 1,880,000. So you can fill it in this way. I called it 1 million. There's 1 in the million. 800,000. 80. And then zeros all the way through. When I write this number in the ones period, I have zeros. In the thousands period, I have 880. And in the one, only in the millions period. So now, what is the value of the 2 8s? Well, this first 8 has a value of 800,000. The second 8 has a value of 80,000. How are those two values related? Well, what's the difference between 80,000 and 800,000? Well, there's one more 0 in each number. You are correct. This has 4 zeros. And this has 5. 800,000 is 10 times more than 80,000. Or 80,000 is 10 times less than 800,000. Let's look at some friends' work and see how they solved. I have Corey and Albert. What do you think of their work? Take a moment to just look at them compared to what we just solved. Do you have one you like better? I agree. Corey's work is much better because he answered the second part of the problem, the how are they related. Albert did not. They just filled in this. Is it okay they didn't put the zeros in for the other parts of the number? Yes, because you can infer that if you have a number in the 1 million or the 100,000s, there would be zeros in empty place values. So the value of a digit changes when we put it in new places on the chart. So for example, if I have a 5 in the ones place, it's 5. But if I put a 5 here in the tens place, it's 50. If I put a 5 here in the hundreds place, it's 500. So the value changes depending on where it is on the chart. And notice, 5 ones compared to 50 tens. 50 in the tens, excuse me. 5 times 10 is 50. 10 times 50 times 10 is 500. And 500 times 10 would give you 5,000. So where that digit is makes a big difference. According to the 2010 census, the population of Phoenix, Arizona is about 1,440,000. What is the relationship between the value of the two fours? They've done the same thing. They wrote the whole number in the place value chart. I have a 4 in the 100,000s and a 4 in the 10,000s. How are they related to each other? And she suggests that writing your number in expanded form could help. In the past, you've done expanded form as 1 million plus 400,000 plus 40,000 plus 40,000 plus zeros. We're going to write it a little bit different. We're going to write it as the digit times the place value. So I have 1 times 1 million. And then I have 4 times 400,000, times 100,000, excuse me. And then I have 4 times 10,000. I do not need to add the other zeros. That equals 1,440,000. You might ask, what's the purpose of writing it? It's longer than the way you've done it before. Why does it seem to be more complicated? There is a method and a reason for this, as you'll find out later in your math careers. The expanded form that we just did together is written as above, and it's also written this way right here. Digit times the place value. 4 is the digit. 100,000s is the place value. So when we do expanded form here in 5th grade, it's going to be digit times the place value. Digit times the place value. Digit times the place value. This is standard form of a number, just the regular number. This is a little fancier way. And we're going to get into exponents of powers of 10. This will be something you'll like much better by the end of the year. If you notice, 1 million is equal to 10 to the 6th power. It's a 1 with 6 zeros. 100,000 is equal to 10 to the 5th power. It's a shorthand way to do it. We'll have lots of time to practice that this year. And the number name or word form is 1,440,000. Actually, I would not put the word and in there personally. I would just say 440,000 because the word and implies that there is a decimal point. So it's 1,440,000. Do you understand me? Well, let's check. In 9,290, is the value of the first 9 10 times as great as the value of the second 9? So when we say first 9, we're doing that by how you read the number. This would be my first 9 because I'm reading that number. So is that value 10 times as great as the second 9? You may be able to reason it, but let's look. The value of the first 9 is 9,000. The value of the second 9 is 90. Is 9,000 10 times equal to 10 times 90? No. 90 would have to be multiplied by 100 to be equal to 9,000. Okay, let's look at another one. Please write this number in expanded form. Please do not write it as 4,000 plus 50. That's the old expanded form. This expanded form, I want it as digit times place value. Write it on paper and see if you match me. I'll wait. So 4 is my digit. My place value is the thousands. I don't have anything in my hundreds place, so I don't need to include it. I have a 5 as my digit, and I'm going to multiply it by my place value of the tens. You will see us doing this a little bit because with all these zeros, it keeps the numbers together. This 4 times 1,000 is equal to 4,000. 5 times 10 is equal to 50. My number equals 4,050. And finally, oops, I'm sorry about that. My writing went over there. In this number, I'll rewrite the number for you here, 7,700. What is the value of the 2 sevens? Pick 2. Right. One is 7,000 and one is 700. Because they are in adjacent place values, they are right next to each other. One is 10 times as great as the other one. And my 2 2s are right here. They are next to each other. This 2 would be 10 times as great as the 2 in the ones place. I have one that is equal to 20 and one that is equal to 2. And what is 2 times 10? That's right, it's 20. So you're going to go on, you're going to do the practice buddy and the quick check, and we're going to record those scores. So do your best work and